Today let us do about basic proportionality theorem, or what we call the Thale's theorem. So this is a statement of that theorem and we will have to prove it. So what the statement say? If a line is drawn parallel to one side of a triangle intersecting the other two sides, then the other two sides are divided in the same ratio. So here what do we have? What figure we have? We see that we have a triangle. So that is the given, okay? So we have a triangle, so we have to draw one triangle. Then what happen in that triangle? We know all the sides they intersect each other, but they say in that triangle we have one line parallel to one side. So when they say parallel to one side, it means because all the three sides they will intersect one another, so we have another line, that means which we have to draw in the middle, and it should be parallel to the third side. So if it parallel to one side, then they also mention intersecting the other two sides. So that means we draw that line in such a way that it is parallel to one side and intersect the other side. So that is the given part which we have to do, okay? So we have a triangle. So draw one triangle. You can give any name. Then in this triangle, you can draw that line parallel to one side. So you may draw it this way, okay? Parallel to this one. You may draw it this way, parallel to this one. Or you may draw it this way, parallel to this. So let's take the horizontal one. It is easy, okay? So we draw this line in the middle in such a way that it is parallel to this side, and you clearly see that it cut it parallel to this first side, and it cut this second side at this point, this side at this point. So you have to name it. Whatever we draw here, that we have to write, okay? We have to write like that. Given a triangle, give it some name. Then we have one line parallel to this one and cut this side at this point and this side at this point. So this is the given part that you have to write. So now we already write the given. Next we have to see what we have to prove. To prove mean we have to see this one, okay? The other two sides are divided in the same ratio. Who divide those two sides? It is this line QR. So if you see from here, from the figure, we have this line QR. So this side PS, it is divided into PQ and QS. Then here at R, it is divided into PR and RT. So this is a symbol for parallel, okay? So that means we have to prove the ratio mean one divided by the other. The ratio, that means PQ divided by QS, it should be equal to PR by RT. That is to prove. So that also we have to write, okay? To prove. In order to prove this one, look at this one. You see we have, this one is a triangle, but here it is quadrilateral. So we have to make it triangle. That is why we will join RS. We will also join QT. Then in order to take the ratio, we don't have any other formula except area. Then we know that area of triangle is equal to half base into height. We have the base here, but we don't have the height. Height means we have to draw a line which make perpendicular to that base. Here we can take PR as the base, but there is no height. We can take PQ as the base, but it's no height. So that is why we will draw the height. Whatever we draw by ourselves, that we have to write in the construction, okay? So we will join these two in order to get triangle. And at the same time, we will draw a perpendicular line which will behave as height both towards the two sides, okay? Because we'll take this as the base, height should come this side. We'll take this as the base, height also should come that side. So we will have to do that as construction. So what we adjust as self, we have to write it as the construction, okay? Now we will see the proof. So remember, we want to get the ratio, so we will have to take the area. We have PQ and QS. Let us see where these two are. PQ we have in triangle PQR, QS we have in triangle QSR. So we can take these two triangle PQR and triangle QSR. We will take their ratio of their area. So remember, the area is equal to half base into height. So this is the base, the height will be this one. Okay, then here we take this one as the base. This is obtuse triangle, so the base will be outside. Okay, so here we see this is the base, this will be the height for triangle PQR. This is the base, this is the height for triangle QSR. Because triangle QSR, it is obtuse, so the base is outside. Okay, we will take that ratio for area. Remember, half base into height, half base into height. Remember, we take PQ and QS as the half base because we want this ratio. Okay, then now here you can see half we can cancel, RA we can cancel, so we are left only with PQ by QS. After that we cannot do anything, we leave that as equation 1. Then next we want PR and RT. Let us see in which triangle they are. PR again we have in triangle PQR. Then RT again we have in this RTQ. So here again we have to take the ratio of their area. So now we take this one as the base. So the height will be the one which turn this side. Okay, so it will be half PR into the base, into the height QB. Then here also we will take RT as the base because we want it. Then the height again will be QB. This one also it is obtuse, so the height is outside. Remember, because the height should be perpendicular. Here again half we can cancel, QB we can cancel, so we are left with PR by RT. Then we can name this as equation 2. If we look at these two, we have PQR, they are same, but QRS, QRT, they are not equal. But from the proof, we want to make them equal. Okay, so let's compare from the triangle what are these two. So if you look from the figure, you will see clearly there we have, remember this two line. Okay, this one QR and ST. From the very beginning we say they are parallel. So if they are parallel, remember the distance between the parallel line, they are equal. So that means the height will be same. Then if you see this one, we have QRT. Okay, we have this one QR. And then we have QRS if you see from here. So we see that mean they have the same base QR from the name itself. Okay, from the name itself we have here QRS. So QR, QRT, we have QR. So that means their base are same, height also same. So what we can say that if base same, height same, we know the area is half base into height. So that means the area of these two triangles will be equal. Why their area are equal? Remember, because they have same base and their height also same. Why the height are same? Because they are in the same parallel lines. Okay, they are between the same parallel lines. So that's why their height are equal and base also same. So the area will be equal. So now we know that PQR same. Area of QRS, area QRT, they are same. It means this left hand side equal to left hand side. Then what we can conclude, PQQS will be equal to PR by RT. Then we get what we want. So we get what we want, that means the theorem is proved. So remember once more, we have a triangle. Then in this triangle we have one line drawn parallel to one side intersecting the other side. That means the first side at here, the second side here. then we will have to prove that the ratio, because this line you see clearly divide this side into two part, here also into two part. Okay, so we have to show that these two ratio are equal. Then in order to prove that, we have to use the area. So we draw one perpendicular height this side, one perpendicular height this side. Then this one, we don't have triangle, we join these two to get the triangle. Then after that, we compare the first triangle with this one. We use half base into height, half base into height. So their base are same, we can cancel. We are left, height are same, we can cancel. We are left only with the base, like here. Okay. Then again, we compare the other side. We have here and this one. So there also we have half base into height, half base into height. So there also half cancel, height cancel. We are left with the ratio. Then if we compare both the triangle, they are same, this one, the upper one. Okay. Then lower one is this one is this one. So if we check the figure here, we see they are standing in the same base, and this also happen to be parallel lines. So that means their height are equal. So when base are equal, height are equal, it means the area are equal. So that is why this lower triangle are also equal. So if both the triangles are equal, both numerator and denominator, we can say that the ratio of the side also are equal. So that is how we prove Thale's theorem. So remember, to apply Thale's theorem, we must have a triangle. We must have one of the line parallel to one of the side. Then only we can apply it.